everybody, this is Meghraj and I welcome you to my YouTube channel. Today we are going to solve the next numerical of electricity. This numerical is taken from the board exam, that is Essay 1 of 2016. So it's for 5 marks, you can see this. Then what is the question? Let's see what is the question here. We use two expressions, h is equal to I square RT and h is equal to V square by R into T for calculating energy consumed by a device. Now, the first expression indicates that the energy consumed is directly proportional to the resistance. So this shows that energy consumed is directly proportional to resistance. Whereas the second expression indicates that the energy consumed is inversely proportional to R. So here you can see the resistance is in the denominator. Whereas that means what? That H, that is the energy consumed, is inversely proportional to resistance. So the question is, how can we explain the seemingly different dependence of H on R? Means these both are the same formulas for finding the H, that is the heat generated, but in the first case R is directly proportional to H, but in second case R is inversely proportional to H. So why is it so? That's what we have to find out here. Now, there is another question attached to this because it is a 5-mark question, so this will be only for 3 marks, and the rest of it, that is these two lines, are for 2 marks. So what was it? Let's see. The current through a 12-volt tungsten filament. Tungsten filament, if you remember, dear friends, if you really remember, what is the melting point of tungsten? This question is going to be asked for 1 mark. That is 3380 degrees Celsius. Keep it in mind. So, the current through a 12-volt tungsten filament connected to a 12-volt battery is 3 ampere. So, current is given 3 ampere and the voltage is given 12 volts across the tungsten filament. Now, what we have to find? We have to find the resistance of the filament. Okay, we have to find the R of the filament, and also we have to find energy consumed in joules in 1 hour by the filament. So in 1 hour, how much energy will the filament consume? That we have to find out. So it's a huge question actually. So let's see how to do this. Now, first of all, you should be knowing the derivation of H is equal to I square into R into T. That is the Joule's law. Okay, so this is the expression for H is equal to I square into RT, and that is our first expression. So in this case, if and only if, listen to me very carefully guys, if and only if I is constant, then and then only you can say that H is proportional to R, or H is directly proportional to R. But if V square into T is constant, V square into T is constant, then you can say that H is inversely proportional to R in second case. So that's what I've written here. And these are replaceable. You can replace I by V upon R by Ohm's law. Okay, so we can write V square, that is, instead of I can write V by R. The square is as it is, R is as it is, and T is also as it is. So this is the expression by Ohm's law. So the same thing will be there. So we will be getting these two formulas, the RHS of these two formulas here only. But the conditions are, listen to me very carefully again. If I is constant, then and then only H will be directly proportional to R. And in this case, the second case, if V square into T is constant, then and then only H will be inversely proportional to the resistance. So that is the answer for the first half of the question that carries 3 marks. So you have to write that in statement here. I haven't written that in statement, but I think I made it clear for you. So what is the next part? Resistance of the filament. So that is V is equal to IR, Ohm's law we know. So 12-volt battery is there, and resistance we don't know, we have to find out. Then 3 ampere current is there. So 12 by 3 will be 4 ohms. So the resistance is 4 ohm. Now what we have to find out? We have to find out the energy consumed in 1 hour, in joules in 1 hour. So we have to use joules as unit for energy consumption. We already know that the SI unit of energy is joules. So for 1 hour. In 1 hour, how much energy will be consumed? We have to measure it in joules. So first of all, before knowing how much energy has to be consumed, we have to find the power. Okay. So we know already in the first video of this series, if you haven't seen that video, go and watch that video first, because all the formulas are written right there. So I've used these 4 formulas that I've written in the first video. So P is equal to W by T, that is by definition, that is work done upon time is power. Another one is P is equal to VI, another one is P is equal to I square into R, and another one is P is equal to V square upon R. So these are the 4 formulas that we already know, and we can use them to solve this value. Means we have to find this value of power, so we can use any of these 4 formulas. So I've used 2 formulas. You can see P is equal to V square by R. We can use that formula also to find the answer. We can also use P is equal to I square into R. So in both the ways, now after solving in both ways, we will get 36 watt as the power. Now what do we know? Energy or work done is power into time. So we already know that power is what? Work done upon time. So if we keep work done in the LHS, what remains is power into time. So we know that the power is 36 watt. So 36 into 1 hour. For what we have to find? Energy consumed in joules in 1 hour. So time is 1 hour. So the energy will be 36 joules. Now we have to convert it in commercial unit of electric energy, that is kilowatt hour. And for that we know that 1 kilowatt hour is 3.6 into 10 raised to 6 joules of energy. Now let's see if you are able to do this. I've left it for you. So let's see how you can do this. So that's all for today, and I'm very sorry guys that I wasn't able to make the video for the numerical of light chapter. I'll be doing that in the next session. So thank you very much for watching this video. Subscribe to my channel and hit the bell icon to never miss a video. Thank you very much.